No, even Ross has one.
All right. So, homework assignment. How did it go?
Easy.
Okay, so super simple. Just so we were introduced to Xcode, so everybody saw how Xcode works a little bit, stuff like that. Messed around with playgrounds. You create a couple of variables, printed out hello world, did a little loop, set it. Okay, so we're kind of adding to our toolbox of things we can do in Swift. So as we mentioned last time, what were you supposed to do for the loop?
Print out 1 through 10, or the loop was a 1 through 100. Print it out.
Okay, that was it.
And then the next, so it was display hello world, then display all the numbers 1 through 100 using a loop, and then display a random number using the R4 random.
Okay.
That is also divisible by 3.
Okay, got it. So, and show how many of those? 10?
10.
Okay, so print out hello world, right? And then a loop that goes through and prints out all the numbers 1 to 10?
1 through 100.
1 through 100. So for I is equal to 0, I is 1. I is less than or equal to 100, I plus plus. Println I. All right, so that's our I 100 times. You can click on this and view the dealio, I think.
I'm pretty sure I was getting errors when there were parentheses around the for statement. Is that just totally wrong? Or do you have some setting or something?
Well, should allow it. I don't think it's required, but it should allow it just fine. Yeah, I personally don't like this format. I like the format with the parentheses around it. So, this kind of gets back to what we were talking about last time about one of the goals of Swift is kind of remove things that programmers don't have to do. Well, understand that there's a difference between symbols having very little meaning in terms of the program parser being able to read it versus the human eye being able to appreciate what we see. This looks a lot more formatted to me. So this line right here with the parentheses around it kind of holds it together. So visually, I think it looks more structured. Where if we take the parentheses off, which technically are not required by the Swift parser, I don't think it looks as structured. So choose your poison, I guess. But I will very likely continue to write it this way, which would be consistent with those of you who know Java well. So this is basically identical to Java with the exception of var becomes int and this becomes system.out.println. Otherwise, it's the same code. All right. And then you're supposed to have use arg for random? The uniform one, and it's supposed to be a number between 1 and that. So that should get us a number between 1 and 100,000, and you're supposed to print out 10 of those that are evenly divisible by 3. Okay, so that means we're going to have to keep track of a count.
So is it actually printing it out for you there?
I'm not printing it yet. It just shows it over there. I was just kind of showing this function. I'm going to grab this function here in a second. So we're going to have a count, and then we're going to say while count is less than 10. We're going to go ahead and grab a random number. So I'll go ahead and actually say var number int. We'll say number is equal to arg for random uniform 100,000. Then we'll ask if number mod 3 is equal to 0. Println number count plus plus. Okay, so this while loop we'll start off count at 0. We haven't found any that are evenly divisible by 3. Then we'll give us a variable, a place to throw our random number each time. Then we're going to write a while loop. This while loop will go through and keep going as long as count is less than 10. We'll generate some random number between 1 and 100,000. Does this give you 1 in 100,000 or 0 in 100,000, this one? do I actually get to see it out here?
It might be that art4 random.
We'll just take that out of here for right now.
It's the one.
All right, we get zeros. Do we ever get a 5? Okay, yeah, no 5. So this should actually be so this will generate a number between 0 and, actually, we want it to be 0 and 100,000. So this would be 0 through 99,999. Add 1 to it, it'd be 1 to 100,000. If you didn't do that, don't worry about it. UInt 32. All right, so here's our 10 numbers. They should all be numbers that are evenly divisible by 3. All right, so just assume that's correct. Make sense? All right, so at the very least, everybody's been introduced to Playground. Now, understand that we're not going to be sticking with Playgrounds forever, just for maybe the first week or so, or the next week or so, as we're introducing the language. Then we're going to move into creating an Xcode project to do Apple Watch stuff. All right, so right now we're kind of learning the language we're going to be using to manipulate Apple Watch stuff. Then we'll start dealing with iOS ecosystem type things, UI views and table views and crap like that. All right, so today, as we're adding things to our toolbox, we've seen a couple of different loops. So we've seen the for loop and we've seen the while loop. Let's see, we talked about conditionals last time. So if Boolean expression, body, we can have optionally an else with that. All right, so that's asking questions. Repetition is our loops. All right, so now we want to give ourselves a couple of additional storage containers. So we have collections of items. So we're just going to call these guys collections. And historically, what we've thought of as collections as being something called an array. Okay, so an array is a collection of like data stored within a single variable name. Something along those lines. Okay, so what we're going to go ahead and do is we're going to go ahead and create an array and then fill it up with some stuff. So syntax for arrays we'll say var ar is equal to, we'll make this an array of integers like that. Is that the right? I think it's like this actually. Yeah, I think that's it. All right, so syntax for a array, just like any other variable, var variable name equals value. This guy is going to be an array. That's what these square brackets say, of this type. So we're going to store ints in this guy. If you need to store uints or uints, you can. uint32s, whatever. Chars, strings, anything you want to store as a collection, you can store inside of an array. This is an opening and closing parenthesis, which actually indicates to us that arrays are implemented as objects in Swift. All right. As we look at the evolution of our programming languages, in C and C++, arrays were very much primitive types. Okay. And we've seen this in our, if we've seen the old Hello World programs, has everybody in here seen me write a Hello World program in either C or C++ at some point? So actually, I think I could bring one up here real quick. I have one actually saved just to reference this real quick. Yeah, so notice here, that this is actually in C. So notice in C that our main method, just like in Java, main method in Java takes in a string array args, right? Is usually what we call it. Notice in C and also C++, main actually takes in two parameters, an argument count as well as the argument values. All right, so the char pointer argv, this is the actual array of command line arguments. This is how many command line arguments there are. Now remind me, what's a primitive type in any language? What would be the definition of a primitive type? Remember that what I'm introducing here is the idea that arrays are implemented as objects in Swift as opposed to primitives.
Just a value.
Well, just the value would be the definition of a literal. I have a feeling you know what it is, you just didn't articulate it very well.
And then when you call it, you don't pass it. You don't pass it a pointer or a memory address. You just pass it itself.
Okay. So I've advertised primitive types as types that are built into the language that are only capable of holding a value. Remember me kind of using that definition for primitives? They're limited to just holding a value, nothing else. Okay? So the idea here is that if these are arrays in C, just trust me, that's how an array is implemented in C. All right? There is actually a slightly friendlier syntax for it, but pointers are too cool. But not much friendlier. C++ introduced a little bit friendlier one. But trust me, this is an array in C. They're primitives because all they can do is hold a value. That is to say, they cannot report how many elements live inside them. That makes sense? They can't do more than just hold values. So now that's why we need really two things in these older languages like C and C++. We need one variable to hold the number of elements that were passed in at the command line and another variable to actually hold the elements. Okay? So C, C++ arrays are implemented as primitive types. Java arrays are under the hood implemented as objects. They act like primitive types, except when it comes to their length. So they act like primitive types on a really weak steroid. Okay? So if we say that objects are primitive types on strong steroids, an array in Java is like a primitive type on a very weak steroid. The only additional feature it has is it can report its length. So if we think about those evolution of our languages, when we made the jump from C++ to Java, one of the weaknesses we would have said that existed in C++ is collections like arrays, which we use a lot, cannot report how many elements live inside them. All right, so it would be handy if they could at least do that. That makes sense? So Java added that additional ability to an array. So under the hood, arrays are actually implemented as objects. I'm just telling you that's the case from a Java implementation perspective. But the only special feature arrays brought to the table was, hey, I have values and I can also tell you how many of them I have. So you no longer have to pass in two separate values to main. You can now just pass in the array and it can report how many elements are in it. Make sense? So again, evolution of languages. But in Java, we then had, if you wanted to do things to arrays, like sort them and autofill them with crap, stuff like that, we had some objects built into the Java API. One was called array, the other one was called arrays. And these guys did different types of things to arrays. That's why we had two different ones. But one of them allowed us to do things to arrays. The other one allowed us to fill arrays with different things or manipulate arrays, that kind of stuff. So in Java, that's how they acted like primitives, where we needed another object to work with them. Just like the other primitive types in Java, like ints and chars and booleans and doubles, we had classes, like for instance, integer. Okay, the integer class exists in Java for doing additional things that we might want to do to ints, because ints can't do them themselves. They can only hold a value. Make sense? Swift is a further evolution of these languages. So Swift looked at our modern languages like Java and it said, hey, what else can we do? And we look at how we use arrays, how we use collections of data throughout our programs. As a general rule, when we're writing software, it's always about using the right tool for the job. When would you use an array? When would you use a collection of like data? It's kind of rule of thumb. It's kind of like, it's the equivalent question to me asking you, when would you use a screwdriver around the house? Or when do you use a chainsaw? We have a tool called an array. When do you use that?
You want to store something, but only want to use a specific words at certain times.
Okay.
So, like,
That sounds very wishy-washy to me. Say what?
like a deck of cards.
Deck of cards is a reasonable example. So when you want to store a collection of things that have something in common, and we want to use them over and over again. So we think about, like, so really let's work backwards off this example of deck of cards. What is a deck of cards? It's 52 very similar things, right? You know, but each one is actually slightly different from the other one, but they're kind of the same type of thing, right? So we want to store them as a collection so that we can go through and we can sort them or swap them out and do different things to them, but we need to work with them as a collection. Right? When we think about a deck of cards, we pass the collection of cards around as we're working with it. Okay, so a deck of cards would be a perfect type of thing to implement using an array. It would, in that particular case, it would not be an array of ints, it would not be an array of strings, it would be an array of card objects. And we define a card object to probably be a face value, a suit, and maybe a value for the game or something like that. I think when I've implemented it in other classes that you guys maybe have had with me, we've usually had a display value, how it shows up, and then also a numeric value, how you treat it in a game, that kind of thing. But, you know, whatever. We'd have this idea of a card object where all cards are very, very similar to each other, but they might have different values stored inside of them. And with a deck of card example, we might want to store a collection of those guys. Okay, so now in Swift, just looking here at the, well, I'll just show you the basics of it, then we'll look at some of the more interesting things that arrays can do. So just like in Java, objects have constructors. And the generalistic constructor for an array takes no parameters, and this basically calls the constructor for an array to go and create a magical list of those things, a magical array of integers. But notice the difference here between this and Java. In Java, we might say something like int array AR is equal to new int array 100, for example. So that might be some Java code, right? What does this create for us? An array, well, an array thingy, whether it's an object or a primitive. Java is kind of a gray area. Capable of doing what? Holding 100 of these guys. So in this case, this line of code in Java will create an array with 100 empty buckets in it, each capable of holding one of these animals. Okay? So in Java, when we think about arrays, arrays have a fixed size. So this also implies that we're going to be taking up a chunk of memory that will have to hold 100 of these guys. Now, if these guys are 32 bits, this is 3,200 bits to hold 100 of them, right? Okay, so 3,200 bits will store this. So 3,200 divided by 8, that's the number of bytes, divided by 1,024, it's 0.39 kilobytes. That's the size of memory that we will need to store 100 integers. Trivia stuff, right? All right. Now, notice in Swift, we do not define, or maybe I should say we do not have to define the number of elements we're going to store. I'm just going to comment out this line for right now so it doesn't scream at us. And I'm going to go ahead and we're going to fill this guy up with a number between 1 and 10. All right, so I'm going to say for var I is equal to 0. I said 1, right? I is less than or equal to 10. I plus plus, and we're going to say AR dot append I. And then I'll just come here and I'll say println AR. Okay? So this is what AR looks like. It's a collection of all those numbers between 1 and 10. And how did I add each one? I appended it to that guy. All right. Similarly, I think this should work. Does that not give us the... I actually think this does work. I think this is just having some emotional issues right now. Can you not add it that way? I know you can change something that way. Can you not add it? So this is saying AR at bucket 0 the first time is equal to 1. 1 is equal to 2. 2 is equal to 3. Let's look at the documentation here real quick. Collection types. I know you can change it, but you could say AR at bucket 4 is equal to 7 or something, but you might not be able to fill it that way. All right, so yeah, so here's a collection of integers. So this is our syntax for creating that. We can append an int onto there like we just did. We can also overwrite the value of some ints to just be an empty array, so that'll change it. This is kind of a neat syntax, but I don't know if it's all that helpful all that often. You know, maybe if you needed to fill an array up with like 100 ones or something like that, you can do, let me just modify this. We'll just steal this and copy it into our code, and I'll show you. So you could do something like, let's just call this sum ones. It's going to be a int, and we're going to have 100 ones. And then I can do a println sum ones. Let's just get rid of this guy because he seems to be causing some headaches up there. So notice now I have a array of 100 ones. Okay, so notice that now this guy's acting more like a constructor. Okay, so when I built this, there's a version of the constructor that takes no parameters and creates an empty array. There's another version of the constructor that takes in a count as well as the number of the values you want to repeat. And notice here that this is the constructor for our array object of, in this case, an int. So it takes in how many and what values are we repeating. Kind of a quick way of filling an array. So that line of code is equivalent to us just creating an empty array and spinning through and filling it with 100 ones, appending 100 ones onto it. Okay? I think also, some ones dot, 1 second. Here's all the stuff arrays can do. So we can append an individual element. We can find out what the capacity is. We'll print that out here in a second. We can grab the first element. We can join two arrays together. We'll remove all elements. We can remove at an index. We can reverse. We can sort. What were you going to say, Abe?
What's the little timeline dealio on the bottom?
Timeline dealio. This guy?
Yep.
That's a good question.
Is it like how many seconds it allows the program to run before it stops? Like if you had a really long playground, that took over that, in that example that you had 35 seconds.
I think it wouldn't really apply. I'm not positive. I don't think it would really apply to this type of stuff. You can actually use playgrounds for doing kind of like mini games and animations and stuff like that. So with that in mind, I think this might play in for seeing an animation run to fruition, because one of the things that playgrounds are built for is they're built to kind of show us the individual steps that go into like calling a function and that stuff, so we can see how it's actually being executed. That kind of thing. So I don't think it applies to what we're doing, but probably that kind of thing. All right, so real quick here, I want to print AR dot capacity. So if I create an empty array, it has an initial capacity of 0. Okay, fair enough. So it looks like the only way we can directly put something into an array is append it, which then gives a capacity of, actually this is interesting. So notice here that as I start filling the array, I filled it up with 10 things. So I kept appending, I appended 10 times. Notice the capacity now though is 16. So what we're actually kind of seeing is how it's working under the hood, and it comes back to how arrays are implemented as objects. When we think about, for those of you who've had the 300 class, you'll be able to answer this the best. Arrays in Swift kind of look like what? What data structure that we deal with in 300 do arrays here kind of work like? Yeah, they work like linked lists, where they start off as empty and then we can add crap to them. The reality is they actually act like something called a vector in Java. And what I mean by that is, with a linked list always has kind of a fixed size, right? If we add 3 elements, it has a size of 3. If we add another one, it has a size of 4, so on and so forth. Where under the hood here, and I don't know what the algorithm is, but there is a guess algorithm for expanding the amount of memory given to this particular array for performance reasons so that it's prepared to take in more data. So even though right now there's only 10 elements in this array, it has a capacity of 16. Right? So as we were adding elements, it had some sort of clock that kept requesting a little bit more memory to maintain the performance of this particular animal, this particular object. That makes sense? All right, so that's arrays. We access them through append. I'll go ahead and just print out the array here. Again, I'm going to copy this line. We can change an element in the array, so I can say AR at bucket 4 is equal to 17. Then I can print the array again, and notice now we have a 17 there. Make sense? So you can certainly access the individual elements of an array like this after it's been filled in, but it didn't appear like I could add something to it. Let me try AR at bucket 0 to 9, so 10 is 17. And print out AR.
It makes sense when you think about it, because otherwise you could technically add it to bucket 2, even if you don't have a bucket 0 or 1.
Mm-hmm.
You know what I mean? So
Yeah.
you might be doing it so that you can't do that.
I would hope, though, that it would give us an error.
Yeah, that's what I would
As
do.
opposed to this. But so seemingly you can modify already created elements with arrays, but you can't actually go and add them using that old syntax. We add them using append. Okay, and we always append to the end. But what if I want to add something at a particular position? There's probably an AR. Well, I can overwrite an individual position. Can I do like an add, replace, range? Yeah, whatever. All right, so those are arrays. Now, we have another kind of animal that we're not necessarily used to working with in Java, but it's become very popular in modern software development. And this kind of animal is known as a dictionary. Okay? Those of you who are used to working with it in Java are probably Android developers. Android developers has a thing called system defaults that you use that is a dictionary. So let's see what a dictionary is. So an array, collection of individual data. A dictionary is a collection of name-value pairs where the name is often referred to as a key and the value can be anything, just like variables. Typically, well, we'll see this here in a second. All right, so that's what a dictionary is. It allows us to hold essentially a whole bunch of variables, a whole bunch of name-value pairs, and those names, the values do not necessarily have to be all the same type, like we have with arrays. All right, so syntax. We notice here, just drawing through, we do have array literals. So if I do want to just hard code an array, I can do open square bracket value 1, comma value 2, comma value 3. We kind of mentioned that already, where you can just create an empty array, open close square bracket. So that would be called a array literal. Literals are just hard coded values. Similarly, you can create an array of strings like this, but instead of calling the generic constructor, you can go ahead and give it an initial value. So that's an array of strings. We have 2 strings initially given, rather than building the empty one and then appending eggs and appending milk. Okay. Similarly, you can do something like this. Rather than advertising it's an array, we're just creating a variable and letting Swift's type inference engine figure out that, oh, well, you shoved an array into shopping list, therefore you must want this guy to be of type array. So from that point forward, shopping list will be an array. Okay, so this is us not advertising the type like we did here, but still giving it the literal value. So this guy will then become that type. Okay. Let's see, we already saw, I'm going to show you this at some point, but I want to get you enough stuff that you can do your homework assignment now within mind. Do you happen to have a power plugin?
No, actually, I don't have mine with me today.
Does anybody have a... I have the new one, yeah. I got 10%, it'd be close.
I'm rocking 39, I'm feeling pretty good.
Thanks. Yep. Let's go here.
I put in these nice power strips for you.
I almost went over to reach it, but then I just decided not to. Mostly that's because I didn't want to bump the laptop here. Sometimes it gets a little... Usually this wouldn't be a problem. My laptop's plugged in all the time, but I just watched 2 hours of Apple event.
I did too, and I was fine.
You're not screen capturing. It takes up a little bit more power. All right, in any case. Okay, in any case, we'll look at this later, but this is how you do concatenation. And, well, hell, we'll just look at it now. So in any case, in Java, if I were to print this out, so let's just go this route here. I'll come back into this. So I'm going to go ahead and fill up this array with some stuff. All right, so that guy has now a count of 10. Count different than capacity. Capacity we saw was 16. Its count will be 10. There are 10 things in there. So if I do println ar.count, we get a 10. Okay? But if I want to make this look more interesting and I want to say the number of elements in AR is, elements are, is, yeah, whatever. In Java, I would do something like this, ar.count. All right, and this should work relatively well. All right, so there's our, very nice, even nicer. Trust me, it says it what we want it to say. And then if I want to add some more stuff, you know, I can do a little smiley face there or something like that. Okay, so Java, if you want to do concatenation, you kind of have to build the stuff out this way. And look at the error message we're getting here. Could not overload the plus sign for the supplied argument. So it didn't like me, since this was an int, it didn't like me using this guy to concatenate on a string. It was okay with it on this side when the left side was a string. Bottom line is that concatenation in Swift follows a new format. So the format here would be this guy. All right. So it's a backslash, then open and closing parentheses, and then whatever you wanted to concatenate in there, put inside the parentheses. And it will treat this as something that needs to be evaluated. So it'll evaluate AR.count to, in this case, 10. Let's see, we'll let us see this guy now. There we go. The number of elements in AR is 10 with smiley face. Make sense? So that's how concatenation works in. So I'll go ahead and steal this here. Actually, I'm not even going to steal it. Let's just throw another slide up. Concatenation. This is syntax is backslash open parenthesis resolve a value close parenthesis, something like that. And all of that can be inside of a string.
Can we clarify for real which one is backslash and which one is forward slash?
This is backslash, the one that's leaning backwards. The one that's leaning forwards is a forward slash or a front slash. I don't think there's controversy with that, is there?
As soon as I started to think about it, I mix them up. So as soon as I started to go with that backslash or forward slash.
Right. I mean, does that make sense how I just explained it?
That makes sense.
Yeah, I'm pretty sure that's the line. The one that's leaning to the back, that's leaning backwards, falling backwards is the backslash.
If you Google backslash, that is.
All right, so that's concatenation. Now let's look at dictionaries. We do have a couple of interesting things. So here's our array still. They had that shopping list array, and they had a question here. They have a function called isEmpty that returns true if there's nothing in it, false if there is. In 470, what would this kind of animal be called? Predicate. Good. All right. That's not applicable to this class, just testing my 470 people. All right, so there's our appending crap. You can also append stuff to a list by doing plus equals. That's like I would say this is syntactic sugar for append. Okay, so plus equals says go ahead and append this to this list. I'm not sure one's necessarily better than the other. I probably like append a little bit better, but whatever. You could also append multiple things, so this allows you to take an entire array and append it to a current array. All right, and it will kind of glue those two arrays together. All right, and this is how you extract an item. So this is Java syntax for getting things out of an array. We can replace an item at bucket 0 with this, but that item, as we've seen, already needed to exist. We can replace several items here. So this is saying replace 4 through 6 with bananas and apples. So I'm sure this is going to be bucket 4 and bucket 5, non-including 6. So if you really had a situation where you wanted to replace two values at the same time that were right next to each other, I guess an opinion I might have with some of the things in Swift is it seems like they've given us shortcuts for things that aren't necessarily that useful that often. I wouldn't spend too much time trying to memorize all these little things because we can accomplish this with just 2 lines of code. Shopping list at bucket 4 equals bananas. Shopping list at bucket 5 equals apples. Then we don't have to remember the funky syntax. Okay? But kind of just like we saw with the emojis, we have lots of stuff that lives in Swift to allow us to do different things. Here's that insert thing. So shopping list.insert, we can insert a value at a specific index, so that won't replace that value. That'll make that value the new index 0 and shift everything else away. We can also remove at an index. We could remove the last element, so this is where it's looking a lot more like a linked list, from those of you who've had CSC390. A loop that goes through an array, so we have a for loop, so for some variable name item, in this case, you can call this dog if you wanted to, in something that is iterable. All right, so in this case, shopping list is a collection, therefore collections are iterable. So this is going to go through every element of shopping list, and each time through this list, item will be equal to one of those elements. So the first time through would be equal to, in this case, 6 eggs. The second time through would be equal to milk. Third time would be flour, baking powder, and bananas. Make sense? This is the equivalent for loop to going through and saying, for var I is equal to 0, I is less than shopping list dot count, I plus plus, and then printing shopping list at bucket I each time. Make sense? So shorthand, so this would be in Java what we call the for each loop. Oh, this is stupid. Nobody should ever do this. Yeah, I'm just skipping that. We're skipping sets. Sets are the math thing where you could have unions and stuff like that. Not unimportant, but something we're not going to ever use. If you get to the point where you actually need one, you'll use it. We're not going to use them. We want to get down to dictionaries. All right, so here's dictionaries, our collection of name-value pairs. Okay, so notice here that we have a key with an associated value separated by a colon. Key associated value. So for example, we can have a variable called airports, and we can define this guy as being a dictionary. So look at the syntax for dictionaries. It's very similar to the syntax for an array using the square brackets, but it takes two parameters. The first one is what kind is your type, followed by a colon, or what kind of value is your key, rather. What kind of value is your key? What type is your key? And then the second value is what type is your value. Okay? So in this case, we have key is YYZ. This is so this is the airport shorthand for it. Dub for Dublin, so on and so forth. We have a count for things in a dictionary, just like we have for arrays, but dictionaries have kind of another layer of complexity to them. We can ask whether a dictionary is empty. But now look at this. This is kind of the interesting thing of accessing elements of a dictionary. So in this case, we have airports at bucket LHR is equal to London. So this is actually inserting a value into that dictionary at key LHR, giving it a value London. So we're no longer inserting at a particular bucket. We're not saying bucket 0 or bucket 1 or bucket 2. We're saying bucket LHR. So we can't have more than one element in there with the same key. Does that make sense?
So would that like added on to the end of it?
Yep. Well, it won't necessarily add it on to the end of it because dictionaries do not guarantee order. It would add it to the dictionary somehow. Okay, but it only exists once. You can only have keys must be unique.
So if there's another one like that, does it get overwritten?
Right here, yep. So right here, we're saying let bucket LHR get overwritten to be London Heathrow instead of just London. This won't add another entry. We only have one index for key LHR. All right. Similarly, we can, so this line right here, airports LHR equals London Heathrow, is equivalent to this line right here, airports.update value. Here's the value we're updating. Here's the key we're updating it for. I don't know why you would ever use this one when you can use this one, but whatever. These two are equivalent. This guy and this guy. Okay? But do notice here that when you do update value, it has a side effect of returning the old value that's being updated. I guess kind of an interesting side effect. This would probably fall into the category of something I would not rely on us remembering. So if I wanted to make sure I got the old value before I changed it, I would do two lines. Create a variable, set it equal to airports at bucket dub, then say airports at bucket dub is equal to Dublin Airport. So I would store it in 2 separate lines rather than relying on my memory to remember that the update value function returns the old value, not the new one, or something like that. I just think it's bad programming construct. All right. So accessing things from a dictionary is very similar to accessing things from an array, except we're accessing them based on key name. Iterating over a dictionary, notice that our for loop looks a little bit different. We have 2 values here. So we have for airport code and airport name in airports. So each time through, the airport code will get associated with the key. The airport name will get associated with the value for that key. So we have access to two separate variables here, and we can then print them out as these are the 2 guys concatenated together. Okay. Notice we can also just get all of the keys right here. So this is saying for variable name airport code in the keys associated with airports. So this will just give you all of those 3-digit, just the keys, the collection of keys. So we can print out all those keys. So those are airport code. We can also get the individual values. All right, so dictionaries hold them together. We have key value pairs, but we can extract the individual keys. We can also extract the individual values, and the keys are going to come out as an array. The values are going to come out as an array. All right, we already know how to deal with arrays. So yeah, and here's proof of that. Notice that airport keys comes out as an array of strings. Airport values comes out as an array of strings. Make sense? All right, so your homework assignment is already up. It's having you go through and create some more logic stuff using everything we've learned now, including dictionaries. And it's to solve this kind of a, somewhat famous beginning programming problem called FizzBuzz, where you take all the numbers between 1 and 100, and I think it's what I gave you, and if the number is evenly divisible by 3, you do fizz. Buzz is another thing, and then FizzBuzz if it's evenly divisible by 3 and 5. So in any case, and then I have you store those inside of a dictionary with the value and the corresponding FizzBuzz or FizzBuzz. Make sense? So when you read the assignment, it gives you all the details, that kind of stuff. But it has you practice dictionaries and that kind of crap. And that'll be due on Friday. Questions, comments, concerns, bribes? All right, I'll see everybody on Friday.